Hey guys, and welcome to the video for combining like terms and simplifying. So in this video, guys, we're just going to cover the rules for combining like terms and simplifying expressions. This is because we're going to be using these skills later in Algebra 2 in order to analyze functions and successfully solve them. And you will know that you are successful by being able to combine like terms in a multi-part expression. So you can pause here. But I'm going to quickly go through the parts of an expression. You have a term, which is a number, variable, or a product or quotient, so multiplication or division of numbers or variables that is added or subtracted in an algebraic expression. So in the following expression, 2x minus 4y plus 7z plus 3, there is 4 terms, each separated by a plus or minus sign. A variable is a symbol, and it's usually a letter, used to represent a quantity that can change. A coefficient is a number that is multiplied by a variable. So in the term 2x, 2 is the coefficient. This means 2 times the quantity x, which is a changing number. In the term x, the coefficient is understood to be 1, even though the number is not written. And finally, a constant is a term in an algebraic expression does not change. It does not contain variables. In the expression x plus 2, 2 is a constant. So what is a like term? It is a term whose variables, such as x and or y, with any exponents, such as the 2 and x to the second power, are the same. So in the expression 5x plus 9 plus 3x minus 2, I have color-coded the like terms. So other examples of like terms here, I have 5x plus x equals 6x. 6xy squared plus 8xy squared equals 14xy squared. Now I want to caution you and say that when you add like terms, especially variables, you do not increase the value of the exponents. So I have seen people do 5x plus x equals 6x squared. Do not do this. This is incorrect, okay? So make sure that you're not adding or increasing the variable exponent amount, because that's not how it works. For unlike terms, so take a look at this one. X squared plus 5x does not equal 6x, or it does not equal 6x squared. You cannot combine them. They are completely separate terms. Same with the one over here. Notice how 6xy squared is different from 8x squared y, so they do not combine to be 14xy squared. So another important property to understand for simplifying and then subsequently simplifying is using the distributive property. If you remember from our video, the properties of real numbers, if a parenthesis contains multiple terms and a coefficient in front of it, the equivalent result is to multiply all of the terms within the parentheses by the coefficient. So if you're going to use distribution to simplify, you should do it first. Here are 2 examples of distributing. And I do want to caution you that this 2 times x plus 2 does not equal 4x. I've frequently seen people go 2 and then x plus 2 on the inside is 2x. So they're combining unlike terms. And then my apologies there. They're combining unlike terms, and then they say that that's 4x. So that's how they arrive at this fake answer here. This is not correct. Do not do this. Do not attempt this. This is incorrect. So if you find yourself thinking that you need to combine x plus 2, you can't. They are not like terms. So I don't think you need to write this down so much as just kind of start to learn it, and I'm going to continually bring this back in. Know the difference between simplify and solve. If you want to simplify, it means you're going to reduce something as much as possible to make an expression as simple as possible by either combining like terms, distributing, applying the exponent rules. And remember that you do not need to do the same thing to both sides when you are simplifying, because there are no sides. There's no equal sign. There's no equal sign. So without it, you can't do the same thing to both sides. If you are solving, though, you do need to do the same thing to both sides because there is going to be an equal sign. There is 100% going to be an equal sign in that equation. You want to do things like combining like terms, distributing first, and then you want to start moving terms around in order to algebraically solve your equation. So I'm going to simplify this. I'm not going to solve it, so I'm just going to put dashed line here to indicate that I'm going to simplify the left side and I'm going to simplify the right side. On the left side, I see 15 plus 10 giving me positive 25, so I'm going to put that here. And then I see 4x minus 3x, and 4x take away 3x is 1x. So x plus 25 is all that I have on the left side of the equation, and that will be equal to, I'm actually going to go ahead and wipe that out. That's going to be equal to, over here on the other side, I have to distribute first. So I will draw my distributive arcs for you guys. So you see 5x plus 6 plus 3x plus 2. And now that I've done the distributing, I can go ahead and combine my like terms. I'm going to collect the 5x and add 3x to it to get 8x. And then you'll have positive 6 and positive 2 for 8. So in reality, the equation, which you could finish solving, has become 8x plus 8 equals x plus 25. So it is also important to be able to know how to work with fractions when you're simplifying. So in this case, what we are going to do is we are going to distribute this fraction to this parentheses as normal and combine any like terms that result. So if I do that, I'm going to get 14 over 5, and that's going to be multiplied by x. So in order to just represent that, I'm just going to write it as 14 over 5, and then x. And that's going to be minus, I have to now multiply 14 fifths times negative 2/3. So in order to multiply fractions, remember that you're just going to multiply numerator by numerator, so that's 28. And you're going to multiply denominator by denominator, so that's going to be 15. And then I'm adding 2 more fifths to this. And so I'm going to switch colors here really quick. Actually, I'm going to use my highlighter. I can then see that these two here are like terms. So they need to be combined. And when I say they're like terms, I am talking about that they are both constants. So they both need to be combined, even though they don't have the same denominator yet. If I analyze these two fractions, I can see that 15 and 5 are two numbers that go into each other. So 15 can be divided by 5. So I'm going to ask myself, what can I multiply 5 by to make it 15? And the answer is 3. And what you do to the bottom of the fraction, you do to the top. So this one will turn into 6 over 15. And that's, you have negative 28 fifteenths plus that, and you still have the original 14 over 5x. So then you'll have, as a final simplified answer, 14 over 5x. And then you're going to go ahead and combine the two fractions here, the negative 28 fifteenths and the 6 fifteenths. So that's going to give you negative 28 plus 6 is negative 22 over 15. So we're going to move on again to using when I have higher powers than just x or y to the first power. Here I have all of these, y to the third, y to the second, and regular y, and then I have the same in the next fraction or the next parentheses. In this one, I do want to highlight this, literally highlight it. The negative sign in front of the parentheses is actually an indicator for you to put a negative 1 in front and then distribute it to all of the terms. So I'm going to do that. And when I do, I get negative 1 times 6y cubed is negative 6y cubed. Negative 1 times negative 3y squared is going to turn into positive 3y squared. And negative 1 minus 10y, or times negative 10y, is going to turn into positive 10y. So then I will have the original 3 up here, the original 3 parts, 5y cubed, negative 5y cubed, plus 4y squared, take away 3y, and then I have minus 6y cubed plus 3y squared plus 10y. So I'm going to use my highlighter to highlight the like terms. So I have this here combined with negative 6y to the third power. And that's going to go ahead and give me negative 11y to the third. So then I'm going to move to the next highest power, and again use my highlighter here to go ahead and highlight the positive 4y squared and the positive 3y squared, which when combined would be positive 7y squared. So I will write plus 7y squared. And the last color highlighter that I'm going to use is going to highlight the negative 3y plus 10y. So if I've got negative 3y and then I add 10y to it, I'm going to end up with positive 7y, and that's how I will write my simplified expression. So the next problem that we encounter is something like this, where it says to add roots, simplify this, and I have these roots here. I have the square root of 7 plus 2 times the square root of 3 plus 7 times the square root of 7 plus square root of 3. When you are adding roots together like these, you can only add them if they are the same variable and or number underneath the radical sign. So it's totally cool to add the square root of 2 plus the square root of 2, and that would equal 2 times the square root of 2. You cannot add square root of 3. Oh, it took way more than I thought. If you cannot add square root of 3 plus square root of 2, though, that will not equal square root of 5. This is not true, okay? Don't do this. Only this is correct. You can only add the roots that have the same number underneath the radical sign. So knowing that, and with that information, I'm going to take my highlighter and say that, okay, I have square root of 7 here and 7 times the square root of 7. So they have the same root number underneath the radical. So square root of 7, there's like a 1 hiding out front. 1 times the square root of 7 plus 7 times the square root of 7 gives me 8 times the square root of 7. And then I'll take my highlighter and do the same thing with green for the square root of 3. So I have 2 times the square root of 3 plus another square root of 3, which gives me a grand total of positive 3 square root of 3. So that is how I would combine these root terms, and it would be as simplified as it can get because I cannot combine the remaining 2 roots since they are different underneath the radical sign. And then the last thing that I need to talk about with you guys is the absolute value. Absolute value, we're going to come back to solving these types of equations in the next section, but absolute value is a number's measured distance from 0. Since distance can never be a negative quantity, this means that a number's absolute value is a positive amount. So if you need to pause to copy this down, feel free, because I'm going to go right into evaluating it here. Simplify the following expressions. You're going to notice in this expression that there are no numbers. That's okay, or no variables. That's okay. I'm just trying to get you used to the idea of simplifying expressions in general that have absolute value in them. So what I can do is, since all of these are within absolute value symbols, I need to take the absolute value of them first, but I have to do the 1 plus 2. In PEMDAS, okay, in the PEMDAS order of operations, absolute value is here, okay? So absolute value is here, and that puts a anything inside the parentheses, like this 1 plus 2 would go first. So I'm going to keep everything else, absolute value of negative 8, not x. We don't use that for times. So times this. So absolute value here, 1 plus 2 is 3. So that is what I am simplifying. Absolute value of 4 minus the absolute value of 7. So what I'm going to show you is that I have taken this and turned it into this. So now what I am going to do is simplify all of the absolute values. So I have done everything inside of the absolute value signs that I possibly can. So we're going to go all the way through, so no more PEMDAs here. We actually have to take the absolute value now. So the absolute value of negative 8 is positive 8 times. So now I have 3 over 4, and I cannot simplify that, minus the absolute value of 7. And when I say 3 over 4, I had positive 3, positive 4. So those are going to stay positive 3 and positive 4 in the fraction. And the negative sign stays here because it is outside of the absolute value symbol for 7, so it stays there. So the next thing to do would be to do the multiplication, which I'm going to highlight in green here. You need to multiply 8 by 3/4. So in order to do that in this scenario, what we're going to have to do is turn 8 into a fraction. In order to do so, we could do 8 over 1 times 3/4. And then we're still going to be taking 7 away from it. So we're going to go ahead and actually multiply that now. 8 times 3 is 24. And on the bottom, 1 times 4 is 4. Minus 7 is how I've simplified. And I'm going to try, I know that 24 is divisible by 4, so I get 6 as the result, minus 7, which means my final simplified answer is negative 1. And so that's it for today, guys. We learned that like terms are part of expressions that have the same variable and exponent. We saw the distributive property is useful for simplifying expressions with variables. We can apply these ideas of combining like terms to higher power expressions and also lower power expressions like roots. And absolute value expressions can be simplified first by applying the definition of absolute value and then correctly applying PEMDAS. So that's it for today's video, guys. Thanks for watching, and I'll see you in the next one.